Good afternoon. Today we are going to talk about interface segregation principle, which is one of the solid principles. So what is interface segregation principle? Basically, the definition for the interface segregation principle is clients should not be forced to depend upon interfaces that they don't use. As the meme says, if required food, I want to eat food and nothing more, like light a candelabra or anything else. How can we structure this with a few examples? Imagine that you have a store and initially you only want to sell jeans in your store, so you define a simple interface that iProduct. You define some simple properties like ID, weight, stock, inseam, waist size, and the class implementation for your jeans basically implements those properties. So what will happen next when you have additional piece of product in your store? Let's say you have a fedora hat, and if we implement the same product interface, one thing that you will find weird is that a hat does not have waist size or inseam, but it only has head size. What is the solution to that, or how to refactor, is basically splitting up the product interface into something more smaller, like one product can have an ID, weight and stock, and we can have additional interface that that's the implementation for pants that has waist size and inseam, and you can have a separate interface just to define the head size. So how will our solution look like after this? You have a class that inherits from iProduct and that inherits from additional interface iPants, and you have all the properties that you need for jeans. If we see that example for the fedora hat, we can see that the hat inherits from a product and from a head property and only has the additional head size, which is not the same as the previous solution where you had inseam or waist size for a head. What are the potential hazards for a solution like this? It tends to grow with huge amount of interfaces. Let's say if you want to add additional item in your store, like a t-shirt or like a long sleeve shirt. If we put that in a cocktail mode, a typical Long Island cocktail has vodka, gin, tequila, rum, liquor, lime juice, cola, and much more ingredients. So basically every example on the internet ends with this example, that this is how you inherit multiple interfaces. This is what interface segregation principle is, but you are not solving this chaos. So let's look at this cocktail example from a bartender point of view. When you order something, the bartender doesn't care what you order. The bartender knows only that he needs to get a glass, to add a certain amount of ingredients like whiskey or bitter, to stir the drink, to add a cherry if you want that, and later to charge you. So how would a typical cocktail interface look like? Basically, taking the bartender approach, we have a glass, we have some ingredient that's called whiskey, we have another ingredient, we have some bitters, we have a certain task that needs to stir the drink, we have another ingredient, and we have another method that we need to charge the customer for that. What can we see from this example is that whiskey, bitter, cherry, or anything else is just an ingredient. So for the purpose of this example, if you define an ingredient with just a name and amount, and if we want to define some sort of a response, for the sake of simplicity, we are only going to define a simple string and a simple implementation of classes like this. So what that actually means is that a whiskey is an ingredient, vodka is an ingredient and gin is an ingredient. So how can we make this mess into something more usable and more generic? Well, what we could do is implement an interface like this using some simple generic magic. You have a defined cocktail interface, you have an input type that says this must add an ingredient, and we are having here a constraint that this must be of type ingredient. Then we have a certain response, and then we have some cocktail to add ingredient. So let's see how we are going to mix a few things. Let's just define a base class that says this is a cocktail base. We have a list of certain ingredients, and let's see our interface from the presentation. It looks like this. Let me zoom it out a little bit. Okay, so first things first is that we are going to define this Long Island cocktail using this interface. So this needs to inherit from our base class and needs to implement this interface, which accepts some type of ingredient and some type of response. Let's just implement what is in our interface definition. So here is how we can add a certain ingredient. What are we going to do now is basically have that list of ingredients that is in our base cocktail base class, add what we need, and return some simple result. Let's call that one and let's just add one property here that says we want to see all the available ingredients from our cocktail. If we want to test something, for example adding multiple ingredients to Long Island, let's see how can we test that. So here we have a unit test which basically will test anything against our Long Island cocktail. Let's see what the test data looks like. Basically what we are adding here, we are adding vodka, dry gin, tequila, rum, liquor, lime juice and cola. Let me just zoom this for a second. This is ensuring that every type of this type data is of type of ingredient. If you look at the definition of each individual item, you will see that they inherit the specific ingredient interface. So if we run this test, basically it confirms that every ingredient that is added contains at least is contained at least once and is from the proper type. How we are double checking that. So we're double checking if this should be of type ingredient. The other unit test is basically inserting all the ingredients that are defined here in the test data. There are 7 in total, and we have a unit test that ensures that all the items should be 7, and then it should contain each and every one of them. So if we run that same unit test again, so this is passing. One thing that we could do differently is modify the base class and how we are actually mixing some things. So if we modify our base class to inherit from that same interface, we need to implement the definition from that interface. And let's do something simple. This means we have to tweak our Long Island cocktail a little bit, because now this interface is implemented in the base class. We can get rid of this one, and we can get rid of this one. Let's just run all the tests again, just to ensure that every condition is met. Okay, so all the unit tests are passing. Now let's do something more different. Let's define a new cocktail, Mojito 1. All we need to do is just inherit from this class, and everything works. If we want to double check that, we can just replace this class. Let's use the Mojito here instead of Long Island. Shoot. Run. Yeah. Probably a good idea to implement something like this so our tests can pass. Okay, so the Mojito 1 works. But what is the point of utilizing the interface segregation principle if we can mask this in a simple class like that? Let's define a certain interface. Shake. And let's just do some simple task like this one. What we could do right now is define a new cocktail, which is the James Bond cocktail. So that cocktail needs to have a glass, and that cocktail needs to be shaken and not stirred. So how will our implementation look like? Since we already have basic implementation in our base class for adding ingredients, these are the two extra methods that are generated for this one. If you want to serve this in a bar, you need to charge money, we can do something like this. And if we generate the missing methods, we can see additional two methods: get the amount of the cocktail and then charge it. Also, we can just chain additional interfaces like this one, but what we could also do is define an interface that looks like this. And this cocktail needs to inherit from a glass, a shake, and let's add the charging part as well. That means that I can replace all of these interfaces here with this one. If we try to delete the methods generated previously that we need to have, you can see that everything is defined here. Any questions so far? In that case, let's wrap it for the day. The source code for this example can be found on this repository. Here is the contact information if you want to specify a certain theme that you would like to hear on some of the next talks, or maybe you have questions. Feel free to shoot an email. Thanks.